Today we're going to talk about triangle inequality. And our main thing that we're going to try to do is we're going to look at the triangle inequality theorem, and we're going to use that theorem to either prove that a triangle exists, or we're also going to use that theorem to kind of decide what would be the best case scenario if in real life if we were placing things in a triangle type setting, like what would work the best. So if you're looking here, all of these segments are 8 long, right? So if we put a point here, A, then that means that BA is 5 and BC is 3, right? So they're equal to 8. And so if we look at this triangle here, if we pull A up, right? So here, point A is on the line, and they were equal. 5 and 3 equaled 8, right? Here, A is above the segment BC, and then we have 7 and 9. And then in this third case, A is above, and we have 12 and 15. So in all of these cases, notice that never will, if we add two numbers together, will it be less than the other side. So for example, if I do 8 and 5, that's more than 3. 8 and 3 is more than 8. 5 and 3 is actually equal to 8, and that means it makes a solid line. Over here, 7 and 8 is more than 9. 7 and 9 is more than 8, and 9 and 8 is more than 7. Over here, 12 and 15 is more than 8, 12 and 8 is more than 15, and 8 and 15 is more than 12. So it's always, if you add two sides together, they always have to be more or equal to the other side. Now, if they are equal, then that means you don't have a triangle, you just have one line. So let's go ahead and review a definition. I want to review the definition of between. So remember, if we have a point M, and it's between A and B, then that means AM plus MB has to be AB, right? Like they have to add up to be the whole thing. And so if we want to say that point M is between A and B, we would use this notation here with a little dash. That means that M is between A and B. Okay, so our big theorem that we're working with is the triangle inequality theorem. And that says the sum of the lengths of any two sides is greater than the length of the third side. So for example, here we have two lengths, 2 and 3. They're not greater than 7, which means that this is impossible. You can't make a triangle like this. So no matter how you move those segments around, you're not going to be able to form a triangle, okay, because you're missing some length. Okay, so how do we use this for real life? Let's say we have a business office, right? And in order to make sure that we get work done quickly, the equipment needs to be arranged very specifically. Okay, so you have someone who primarily uses the computer at her desk. So we have a computer, and then a photocopier, and then also a fax machine. Okay, so we have 3 things that she's using a lot. Okay, and so she's going to arrange those 3 things, the computer, the photocopier, and the fax machine. She's going to arrange them like in a little triangle, and so that way she wants to make it to where she uses like they're close to her. So the total distances, like if you add all 3 distances together of that triangle, she wants them to be less than 20 feet if you add all 3 distances together. Okay, and so she also said the distance between the desk and the photocopier. So remember, the desk has her computer on it. So between the computer and the photocopier, that needs to be the shortest distance. Okay, that has to be the shortest distance. Okay, and then the total distance can't exceed 20 feet. So if we were to use this, right, if we said the computer to the copier, all right, so the desk to the copier, if that was 5 feet, that's okay because that makes it the shortest. Remember, her desk to the photocopier needed to be the shortest. And then, is it a good idea that the copier to fax is 7 and then the computer to fax is 6, right? So the other sides are 7 and 6. This would be okay because this makes a triangle, right? Regardless, option number 1 is a good option, okay? Option number 2, even though we still have the shortest side being the desk to the photocopier or the computer to the photocopier, it's the shortest side, but notice how the copier to the fax is 6 and the computer to the fax is 9, but if you add them up, 3 and 6 is equal to 9. So this is not a triangle, this is actually going to be a straight line, which is not what you don't want. So option 2 doesn't make any sense because it's a straight line. Okay, so let's do some practice problems. Can a triangle that are constructed with the segments of length 5, 8, and 13, can you make a triangle out of that? Yes or no? So the answer would be no, and the reason why, because 8 plus 5 is more than 13, okay? However, if you do 13 and 8, that's more than 5, right? And then 5 and 13 is more than 8. So it doesn't work, right? It doesn't work. And then also, if you think about it, 5 and 8 is equal to 13. And if 5 and 8 is equal to 13, remember anytime you add them together and they're equal to the third side, you don't have a triangle, you actually have a line. What about 4, 6, and 1? This one is no, because 4 and 1 is 5, which is less than 6. So remember, they have to always be more than the third side. Okay, what about if we're given two sides of a triangle that are equal to 4 and 7? What is the range? So this is not asking for the specific third side, but the range of possible values for the third side. So in order to calculate this, we need to think about this. So the third side, right, the third side, it has to be less than the 4 plus 7, right? It has to be less than 4 plus 7. So our third side has to be less than 4 plus 7. But it does need to be more than 7 minus 4. Like, it needs to be more than the difference between the two, right? So that's how you calculate it. It has to be larger than 7 minus 4, so that would be 3, but it has to be less than 4 plus 7, which is 11. So our range is between 3 and 11. So anytime you're doing this, the third side is always going to be greater than the difference, but it's going to be less than the sum. Let's try one more. Given two sides of a triangle that's equal to 9 and 18, which of the following is a possible length for the third side? So remember, it needs to be more than the difference, but less than the sum. So the difference between 9 and 18 is 9. So it needs to be more than 9, which crosses out option 1 and 2. However, it needs to be less than the sum. So 18 plus 9 is 27. So the only thing that's less than 27 but greater than 9 is going to be option 3, which was 12. All right, go ahead and try some problems on your own.